We'll commence right now. Okay. 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 Yeah. Okay. Yes. This one. Okay. So we have a completing function and identifications. So all those things, you will see them on your P&ID. And at the same time, though most of the instruments, you won't see the instrument on PFD. Because PFD only give the, the links between the equipment and at the same time the flow lines. Whereas the details of that drawing will be, you will see them on your P&ID. So we have instrument abbreviations there. So your instrument abbreviation, we have for analog input, you have it as A1. So if it's a programming logic control, you have it as PLC on your controller. Then if it is your process variable, the lock close, lock open of your valve. So I think we've explained the others one on the first day of our PID, but let's just do some recaps on it. The lock close and your lock open. As I said, we have some valves on your flow lines or within the facilities that are always lock open. That is on, they are always in lock open position. And of this, the other one, we have them as what? Lock close during an operations. So they are always in open position, then you now padlock them. So that at every point in time, the flows within those lines is always, the valve there is always opened. Then if it is closed, then it means that at every point in time, the flow on those lines is always what? Locked. So that is that. We have a normally closed and normally open, that is NC, and some valve, as I said, they are still the same thing as a lock open and lock close. Then we have the process variables that are there within your flow lines. We have the set points. So we have set points, and we have elevation. The set point we have there is all mostly on your PSV and PRV, which you do your set point for. That is, if those the pressure safety valves there, if it sees the pressure above what you designed it for, then it has to open. That is it's a command. So that's that is you put them at the set point pressure. So you have elevation of those your routes of your flow lines. So the elevation can be positive, can be negative. So that is up there will be positive. Then when it's going down, when you bury them, they become what? Negatives. So then we have some connection or some flanges there. So it can be threaded. You know, when we say something is threaded, we use for example, if you have your bolt and nut, if your if your bolt is threaded, then your nut, it will be very easy for you to screw. So that is exactly what we have. What we have in the connection of those pipes. You use your flange there. Then we have another one that's butt weld, and we have a socket weld, and at the same time we have a what? A flange. That is at the two ends. There is a flange. When you look at the two ends, there is a flange. There is a flange there. So those are the connections within the pipes there. That's okay. We have the table, which the levels tables. Yeah, the levels tables. Those are the alarms that you have within the facility. So you are bound to have those alarms there to control the levels. Because there are other 4 things you control. You control the temperature, you control the pressure, you control the flow rates as well. So those instruments, I mean, those if your level goes beyond what is supposed to, for example, if you are filling a tank, you are suction a tank with a fluid from the pump to the fluid. I mean, from the pump to the tank, for example. So we have within the tank system, we have what we call low. We have what we call LL, low within the fluid. So, for example, if you are if there is a suck in to the tank, then you have the outlet as sucked out. What I mean by suck in, that is the inlets. We have inlets to the tank. For example, let's use a tank on this alarm as a case study. You have a tank, for example, that you are storing your crude. You will pump in the crude to the tank. Also, when the tank is full, you need to discharge the crude, the content of the tank. That means it will come in as an input. It goes out as what? Output. That input is the suction. Then the outlet, the output there is the what? Discharge, which is the inlet and at the same time the outlet. So we have a ways of monitoring the levels within the tanks, because it's not possible. You cannot see the crude as the crude is going in, is filling the tank. It's not possible for you to see the crude inside the tank. So, but with the help of the instrument, we are able to control, to monitor the levels at which the fluid is rising within the tank. So we segment the levels as either low. Then we have low, we have low, we have low. After low, we have low. Then we now have high. After high, we have high. So at every point in time, you program your alarm either to switch off or to switch on. So the alarm will switch on when it sees that the levels has gone below what is supposed to, the levels you set it to be. That is, have gone low, the alarm will trigger that this level has gone down drastically. Then the response from our control bar, which is what we call the one I told you that we have LC, that is being controlled by either pneumatically or hydraulically or electrically. There is a signal that will send to that valve to give a command, because the alarm has already triggered. So it will now rest, it will now listen to what the alarm said. Let's put it in that way. It will listen to the alarm. Then the command, it will now give a signal that, okay, what is the meaning of this alarm at this point? What happened to the content of the fluid in the tank? Is it that it's low? They will now interpret. So if it is low, below what we call low, what will happen? The pump will stop from the sucking out, from the discharge, if it's low, because the fluid is going out of the pump, I mean of the tank now. Then we now close the valve. The alarm will send a signal that LC should close that line, the discharge line. When that discharge line is closed, that means there is no content withdrawing out of the tank. What will now happen? They will now give a command to the inlet of that valve, so that, I mean, to the inlet of the pump, so that the pump will now suck in more fluid to the tank. So the level it will now start to build up, building up again, until it reaches a level that's what we call the high, based on what you program or you set the levels to be. If it is high, then what will happen? It will now give a command also that is as reaches that level. So at that level now, what will happen? The alarm also will trigger, and the response or the command will now be made for the valve to what? To open, so that more content will be withdrawn, and where it's coming into the tank, where it's sucking into the tank, they will now give a response. I mean, a response will now come to close that valve that is feeding the tank and open the valve that is going out of the tank, so that the levels will begin to go down again. So that is how the alarms used to work on those and our instruments, either the tank or the separator. If you look at it, we have alarm of low, which is stopped at 2104. That is, when you seize it at low, that is, the level now is 2104. It's a low. So for suck in of that pump is what? 2104. For stop again is what? 2103. And for start is 210. So when you see that one now, you say alarm at high, which is level alarm high, which is LAH. Then we have level, the other one, which is LSH. Then we have LSH2, and we have a LAL, which is the bottom down, which is the reference to the what? Low alarm level of that one. So that is how they are working. So now, no, okay. Let's move on to to the site. Let's see what is there. Some time factor. Yes, move on. I think we'll explain this one. So yeah, we have some symbols of flow meters and some flow elements. Yes, no, keep on up. No. Okay, we have some control valve actuator, which I've already explained, that will receive a signal. If you look at the valve mounted IP DI converter, you will discover that we have a line that is coming into LY there. So if you look at that line now, you will see that the line is hash. So it's hash. You see hash in here, and you see hash out. That is what connected to the valve. So that means this one now is a control valve that is controlling this diaphragm actuator to open or to close. So the response now is what? Is from is a pneumatic controlled. So they are control valve pneumatically controlled. So if you look at the second one, it's also a control valve of solenoid. So, and that is how we have different form of those controlled. So, but by the time you will enter the P&ID properly, you now see how those actions are being worked. So if you look at the next one, which is a primary flow meter, yes. So yeah, primary flow elements, again, we have them. So they are also part of the one we have there on this. So now, if you check our P&ID now, this under the is still the yeah, okay. So we have service conditions. The flow service condition code of the code. We have code and standard we use for all those things. But before we move on, let's just look at a summary of what we've just explained on that first yeah. So if you look at the drawing inside that block, we discover that is divided into 3 segments. One, we have what we call a title and revision block. Title and revision block. So move on. So the title and revision block is the one on a higher. Yeah, and this is where you have the company name. So it divided into 3 stages. The first stage is at this point where you have your P&ID legend sheet 1 and instrumentation and valves. So that's P&ID for you. But I will explain it on this legend sheet because it's still the same thing. You just put your, we have the back sheet. Yeah, what we call the back sheet. It's a back, the back sheet is nothing but where you extract your drawing, where you put your drawing either the back sheet, either the legend sheet or the drawing itself on the P&ID. So the back sheets there were divided in 3. So we have a title and a revision block. So the title and the revision block, that is why we have the P&ID sheet 1 and C2, and where we also have the project number. So each company will have the project number and drawing number. So the drawing number and the project number and the P&ID number is the work of the DC, that is the document control, to generate the drawing number and the P&ID number and the drawing numbers. So, but what we have here, we will see at what? D001 simply means drawing number 1, D number 1. So the project now will be what? We just give a name as 1, 2, 3, 4, 5, 6. That is the project name we'll have here. Also, the legend sheet will have its own. As I said, we have legend sheet 1 and legend sheet 2. So of P&ID. So it depends. So it depends on the legend sheet, different legend sheet we have. So we have a revised data and we have a company details. It will contain under the block, our block revision block title there. See them. So we will have what we call a revision dates. A revision data will be there, which what we have there. Then we have a company details. The company details, that is the company names, and at the same time the logos of the company will be there. It's also part of that title and revision block. We also have a title. The title we have there is under the P&ID. What is the title of the drawing we have here? So on this one now, we can, instead of putting P&ID here, we will just put legend sheet. Yeah, P&ID. We can even remove the legend, P&ID. We simply put as what? Legend sheets. Legend sheets of our P&ID. So legend sheets, we have legend sheet 1. If you look at the one at the next below this one is 2. That is why we have sheet 1 and sheet 2. But this one we are dealing with is still sheet 1 of legend sheet. The second one will be what? Legend sheet 2 of our P&ID. Then the drawing is also contain what we call a drawing number, which is I gave as what? D001. That is what we call title revision block. That is on that one. The second one, we have a notes block. So our notes block here is nothing. Is anything? Okay, nothing. Yeah, moving. So when it comes to the real P&ID, where we have our drawing, this note now will be at the left corner or the right corner of the drawing. Where you have your drawing, they will put a note there. So that note now, whenever they make, for example, if they put a flange and put something like a revision cloud, if they cloud it, say that maybe that cloud there will simply implies that it's a scope of work. For example, if there is any modification within the facility, an existing facility, so we know the modification now or the revision can either be on the green field or the brown field. So the green field and the brown field simply means the old, if the field has been used, is in use, then, and we have another one, the existing facility and the new facility. That is what we mean by green field and what? A brown field. So now we have a note there. That note now, for example, if you need to add what we call a joining of the pipe. If you are joining a pipe, then you put something like, okay, at this point, you have, you put a note that I'm joining a pipe at this point. So what at that point now, maybe you can have a box and put 2. So the meaning of that 2 you put there, you go back to where you have your notes and define what the meaning of that 2 is. So if you put a hash there inside your drawing, you go to where the note part of that, the corner there, and explain what you mean by hash, so that by the time your drawing is going to be reviewed, then the person in charge to review the drawing, okay, well, what is the meaning of this 2? He put 2 here. What is the meaning of this 2? Or he put cloud here, or he put a hash here, or he put a line and hash at the bottom. So everything there has meaning. If you put a line and hash it at the bottom, simply means that line is buried. So, but you will not explain in details in your drawing. You will only go back to where you have the note part of that drawing. That is where you are going to explain the meaning of that hash at the bottom you have there. So that is under that one. So now you will have your drawing there. So you have a revision. So revision, it can be revision 101, revision 2. So as you are putting your revision, you put it with respect to date. If you look at the one we have here, we have 0708/05. So what is the number you allocate to that? What is that revision you want to review there? Then who is doing that revision, is doing that work at that moment? That is what under by. So the by now, you only put if your name is Blessing Ayo, you can put BA. That is the contract form, so that it will just be equivalent to the size of that the column under by. You just put BA, Blessing Ayo, then dates, then approve. Who approve it? After you draw, you put the note, because you say by who, the date of who carry out the work. Then the person that is approving it, the person that is reviewing it. You understand? So now he will put everything under it and put the date he review it. So if you look at you see issue dates, the day you issue it out for review. That is, okay, I've done my own part. Maybe you are the one that generates your legend sheet, for example. So you are not as you generate it, you are not the same person. The same person that generates will not be the same person that is going to review. So you have to give it out, and what we call the IDC. If it is within the design firms, we call it IDC, internal disciplinary check. So they have to do a check. So another person has to do the check. You issue it for check. That issue date will be 210. Then issue for what? Is it review? When you review it, then after review, if it is okay by the person that is reviewing, they have to approve it. So it will now go from issue for review to issue for what? Approve. That is what we call issue for APR, approve. So those are the notes. Now, if you look at under this one, we have the drawing copies of this drawing and all information contain all these things. Down, there are also a note. That is a part of the note we are saying. So the next one there is what we call a drawing and description block. So the drawing there, the drawing and description block we have there is nothing but the whole space you put your drawings. If it is drawing, the whole space, like this first one we are dealing with, is under still the legend sheets. So everything under the legend sheet, everything will be referring inside this page is what we call, that is drawing and description blocks. So that is the segment of this P&ID. That is how it's been divided in 3. So we have title, our revision block, we have note block, and the third one as what? Drawing and description block. So that is that on that legend sheets. So the next one there is nothing but is still an information on everything you are going to see on your drawing. That is what it means. So, and the method of naming your instrument. If you look at the fluid service, it's telling you that is your line, is it carrying the, what is it carrying? Is it carrying oil? Is it carrying gas? Or is it carrying nitric acid? Or is it a sulfuric acid? That is what they mean by fluid surface. What is that line meant for? What is that your pipeline designed for? What is it carrying? So the next one, we will now have the equipment type code. So for every equipment you are going to use, you make reference to those legend sheets. So we have fluid. If you have a compressor, you have a blow-by, you have a feeder, you have a mixer, you have a heat exchanger, you have a tank, storage tank, you have vessel, you have pump, etc. So those are the equipment you are going to use. And we have different the representation of those equipment. So you don't just go to the drawing and start drawing. Everything, if you are going to use the types of the what is it called? A conveyor belt you are going to use is the one you have on your legend sheet that you are going to use throughout your drawing. So if the types of valve, for example, the first one I explained, we see how they represent the ball valves there. So the ball valves, you must not go and bring another legend sheet different from the one you are using. So the legend sheet has to tally with your drawing. So your insulation symbols is your pipe. Are you insulating your pipe? Maybe, for example, if your pipe is carrying a gas, for example, and it's the terrain that the pipeline is crossing, maybe the temperature there is very cold. If the temperature there is very cold, compared to the temperature of the gas flowing, you are bound to have what we call a freezing. So your gas is going to freeze. It's going to freeze, and once the gas is freeze, what will happen? There's an explosion. So for gas line to cross from one temperature, I mean, from the temperature range at which it's designing for to another temperature is a problem. So how do you cater for that problem? So it's either you put you insulate your pipe either with the help of what we call a heat exchanger, so that it should keep on warming and maintain the temperature of that your fluid within the pipeline, or you put that is heat exchanger with, or we put what we call pipe in pipe. You don't use pipe in pipe, you use heat exchanger, or if you can't use heat exchanger, you use what we call a methanol. You inject your gas line with methanol injection. So those are the things that will keep on the line, I mean, keep on the pressure, maintain the pressure of your what we call of your fluid at that point, your gas line. So that is the insulation we have there. Then another one, we have the line number, the line numbering, and the valve tagging. So there is a way you tag your valve, and there is a way you tag your line. So the way you tag your line, the way you tag your valve, and so on and so forth. So the other one we have there, if you look at it there, you'll see the what we call the MC tag and label of what we have there. So that one is telling you the arrowhead is telling you, is pointing, saying that your fluid is coming from where is it coming from, and where is it heading on to? Is it coming from sheet 1? For example, if you are doing your P&ID drawing, you might have more than 4, 6, or 4 or 5 drawings. So the arrows now will not tell you, it shows the direction from one point to another. Maybe it's coming from the ledger sheet 1 to ledger sheet 2. So those arrows will now indicate the direction of the drawing, and also the drawing number of that P&ID. This has to be there. The drawing number of the fluid has to be there. The drawing number of where it's going to, it has to be there. So, but by the time we enter the real P&ID, we'll understand it better, those direction and the flows of those arrows we have there. Likewise, we have the hand wheel and the tag wheel and so on. So we have the drawing file number we have there. So different companies will have what we call a different numbering patterns. So the numbering pattern of the company A might be different from company B. So, but the line number we have there, for example, if you have maybe a line is 3 inch, for example, so the first one, the numbering there, if it's 3 inch, then that one is line number. Then the second one might be 2 alphabets. You have 2 alphabets, which is what we call a line legend there. Then we have area, and we have line numbers. We have insulation of that pipe, and we have insulation specifications on those ones. So now, when you look at the tie-in point or nozzle point we have there, which is TP, the tie-in point, if you look at the way this arrow is pointing, it says tie-in point bubble, unique identification, and tie-in nozzle. The tie-in point TP hash is pointing towards the ball valves. If you look at the 2 sides, you see that 2 where the TP enter, that 2 lines is called flange. That flange there is telling you that you are hooking, the tie-in point is also known as hookup point. That is the point of joining a line with a flange. That is what we call a hookup point. The point of joining when you are connecting two things together. Now you want to tie in, you want that place that is a flange. Remember that line is coming, is a pipeline. You want to connect it to that flange. So at that point now, you put your TP. TP there simply means you are hooking up, you are tying in a line to that flange before. If you look at that 001 now, that middle is a valve that is there. That valve now, which is 100 before, it now entered the flange that is hooking up to the what we call to the tank itself under the specification, and so on and so forth. So let's move on to the side and see what we have there. Then we have what we call the name of the tank. The name, for example, the name of the tank. You have name of the tank. We have what we call a design API. So you always design, whenever you are making a design, either for tank, either for flow line, we'll consult what we call a reference. So this one now is an API 650. It's a recommended practice, API RP, recommended practices 550. That is the design manual reference you have to consult for you to design the tank. So if you are designing a tank, that is the specification, code and standard. You need to consult. So, and so on and so forth. But at this point, I think we are going to wind up or draw the curtain for today's class. So if there is any question, addition or subtraction, let's see.
So if you have any question, you can get your question.
And just entertain question for 5 to 10 minutes.
Any question? Any question? If you have any question,
addition or subtraction,
you can raise your hand or you send a raise hand emoji. Any question?
My question is,
okay. Please, Sodimu Sumbo, increase your volume.
Yes. My question is, what is divided into 3 segments? I just joined you. I just
threaded.
Divided into 3 segments. It is title and vision block. First stage P&B. What is P&B? Back is divided 3.
Hold on. Please raise your volume again. Your voice is quite low. Please raise the volume of your voice.
I said, you said, what is divided? You said something is divided into 3 segments when you make the summary.
Oh,
I joined when you were about making the summary. It is, so I don't know, you are talking about P&B, and you talked about drawing and description block. You talked about this kind of PA, contract form or whatever, date, approved. Although I understood that, but...
Okay, before he answers, very soon, this time will elapse. So please, we're going to connect back because aside the questions, there are some information we're going to pass across to you people, please. So if it goes up, please, let's connect once again. We are already done. We won't spend much time anymore, apart from the questions and the information we're going to pass across to you guys. So you, Mr. Kyle, the engineer, Kyle will take care of your question.
Okay.
If I get you clear, you made mention of a
3-way valve.
Is it 3-way valve?
He said she came in and she had to lay something. It was 3-way valve.
3-way valves, no?
Yes. It was 3-way valve.
I mentioned 3 drawing this thing. Is it the one on the valves? Is your question on valves?
No, we are talking about he said it's divided into 3. You are making summary. Say it is divided into 3 segments.
Okay. I think I get you clearly now. I said that the P&ID. The P&ID. Are we together now? That's yes. What we. It's either the P&ID and what we call a back sheet. The back sheet is nothing but the the frame where you put your drawing inside. So it's where you put your drawing inside. So I divide it into 3 stages. I said the first one, we have a title and revision block. So the title and the revision block, I segment that one in 4 stages. I said the prime one, I have a revision details, where you have a revision details on it. So I have the company details, that is the name of the company, and the details will also be there. So the prime 3, I said we have title of that, the P&ID, the title of that P&ID. What is that? Is it the legend? That one, is it a legend sheet? Is it a P&ID? So that is the 3rd one. But the 4th one, we have a drawing number on it also. So it contains a drawing number. You have a drawing number and so on and so forth there. That is the first one. So the second one, we have notes block. The notes block. So that is where you are going to define some the items you have on your drawing. For example, if a line is buried, for example, if you have a pipeline that is buried, you know, understand what I mean by buried? It's on the surface. Now you now bury it on the ground. So there is a way you represent it. You can draw a line on that at that place and hash it at the bottom to the client. Now they will understand that, oh, this place is buried. You understand? But it's not everybody that will understand that one. So it's under the notes you are going to explain that one there. You understand? And the condition, then the distance that the buried pipe, the distance it travels is also there.